All right, this is for Math 129, and we're going to do 6.2 notes. Just a warning before we start, there's a couple of things that we're going to skip just for time's sake, because I don't think it's that important for you in the end. So recall that the unit circle is the circle with a radius of 1 whose center is at the origin. So if you have the unit circle, if theta is the angle measured from the positive side of the x-axis to any point. So if you look at your picture, here's your unit circle. It's of radius 1, and they're giving you a theta. It's measured from the positive side of the x-axis, not the negative, the positive side of the x-axis. So for example, here is my theta here, and if you look at the point where it intersects the unit circle, you're going to call it xy. So let's kind of look at what those points would look like if we look at different thetas. And you'll notice as we go through these, all of these thetas are quadrantals. Remember, those are angles that have their terminal side on one of the axes as opposed to inside one of the quadrants. So if theta is equal to 180, well, 180 would be right here. And all it's asking for is, what then is the name of this point? Well, you can see this point is at -1, 0. If my theta is 270, well, 270 is down here. So if I look, what is the name of this point? That point is 0, -1. If my theta is 90, you know that that's up here. What is the name of that point? I think we all can agree that point is 0, 1. 360 is a full revolution. So we end up right back here, and that point would be 1, 0. And of course, 0 degrees means you don't move anywhere, so that's going to be exactly the same thing. 0, oops, 1, 0, sorry. -90, now remember, negative angle, we go down clockwise as opposed to counterclockwise. So -90 degrees would take us back down here. And we can see that that is 0, -1. Hopefully you can see that -90 degrees is exactly the same as positive 270 degrees. So here's a big thing. The sine function, denoted by the sine of t, or the sine of any angle, associates each angle t with the vertical coordinate, or the y-coordinate, of the point specified by the angle. So in other words, if you look at all of these points, what this definition is going to tell you right down here is that the x-coordinate of the point of intersection at the unit circle is your cosine of your angle, and the y-coordinate is the sine of your angle. And that's how the unit circle works. If you can just find the points where your angle intersects the unit circle, the cosine is the x-coordinate of that angle, and the sine of that angle is the y-coordinate. And that is simply what you're doing when you're looking at the unit circle. So for each of these up here, the x is the cosine. So if I'm looking, for example, at 90 degrees, the cosine of 90 degrees is 0. The sine of 90 degrees is 1. So that helped you with all of your quadrantals. So now doing this example 2, knowing this relationship, it says use your calculator set in the correct mode to verify the answer. So we're only going to do a couple of them, but I want to make sure that you understand how to put your calculator in the correct mode. So for example, if I do the sine of 180, now if you go to mode, you can see that my calculator right now is in radian mode. I need it to be in degree mode. And now if I want the sine of 180, so press the sine button, and 180 degrees, you can see I get 0. And that's exactly, if we look at 180, that point up here was -1, 0, cosine, sine, the sine was 0. Now, though, we're also going to do the sine of 3 pi halves. Notice that is in radian measure. So I'm going to go ahead and I'm going to change my mode. I'm going to change it into radians out of degrees. So if I want the sine of 3 pi halves, now remembering, and you can change 3 pi halves into degrees. 3 pi halves is actually 270 degrees. So I should be getting a -1, because if I look up at number 1 and if I look at 270 degrees, I see that the sine, which is the y coordinate, is -1. So that's what I should be getting. So if I do the sine of 3 pi divided by 2, and you can see I get -1. So we're not going to fill in all of the rest of those, because quite honestly, you can look up here and you can fill them in, remembering that the x is cosine and the y is sine. I just wanted to make sure that you are able to switch back and forth in your calculator between degrees and radians, because you're going to have to do that. All right, so now that we know how to find the sine and the cosine, we know how to find all 6 of our trig functions. So if we look here, if t is a real number, so it's an angle, that's a real angle, and your point xy is a point on the unit circle that corresponds to t, so that's your angle. As long as x does not equal 0, the tangent function is going to be your y over your x. So it's the y over the x. Cosecant. Cosecant is the same as 1 over sine. So cosecant is 1 over sine. So that would be 1 over y, because remember, the y part is your sine. Secant is really 1 over cosine, and I'm using theta, but t is the same thing, so that's 1 over x. Cotangent is 1 over tangent. So if I take 1 over y over x, it's simply going to flip it to make it x over y. Okay, so you've done trig before. This should be nothing new. So let's look at example 1. Find the exact values, and this is going to be a lot of algebra, of the trig functions using a point on the unit circle. So they're telling me that here is my point on the unit circle. This is my x, this is my y. So we want to find all of our trig functions. Well, we know that sine t is simply the y coordinate, so that's going to be 2 root 6 over 5. Why don't we just, for fun, let's go over to cosecant. CSC is how we abbreviate cosecant. And remember, cosecant is 1 over sine. So if I want to do that, all I'm going to do is flip the sine. That's how you do 1 over, and then you get the radical out of the basement. And you're going to end up with 5 root 6 over root 6 times root 6 is 6 times 2 is 12. Okay, well, that's down to cosine. Remember, cosine is the x-coordinate of the point, so that's going to be -1/5. Secant is the reciprocal of that, so that would be -5 over 1, or -5. Tangent's going to take a little bit more work. Remember, tangent is the y over the x. So that would be 2 root 6 over 5 over -1/5. Whoops, it might help if you could see that. So if we do the math, the 5's are going to cancel. And you're going to get 2 root 6 over -1, which is simply -2 root 6. The cotangent, which is our last one, is the reciprocal of the tangent. So I'm just going to do negative 1 over 2 root 6. There's the reciprocal. Multiply both top and bottom by root 6 to get rid of the radical in the basement. And you're looking at negative, excuse me, negative root 6 over root 6 times root 6 is 6 times 2 is 12. And there you go. So no matter what your point is, if you're given a point, you can always find all of the 6 trig functions by just using those relationships. Okay, so up here, it's asking us to fill in just the white part for right now. So remember, for all of these are all of our quadrantals. Okay, so first of all, let's just go ahead and fill in the degrees. So 0, and actually this degree sign shouldn't be there because it's 0 radians. This is 0 degrees. Pi halves, if you multiply 180 over pi, you can see that that's 90 degrees. Pi is 180 degrees. We talked about the fact that 3 pi over 2 is 270 degrees, and you can work with these and multiply them by 180 over pi if you want to. And 2 pi is 360 degrees, and of course we know that that is the same thing as 0 degrees. So if we kind of draw our circle over here, remember this is 1, 0, this is 0, 1, this is negative 1, 0, and this is 0, negative 1. So those are our points. So if I want the sine of 0, well, the sine of 0 is the y-coordinate, so that's going to be 0. The cosine of 0 would be 1. The tangent, remember, is y over x, so that's 0 over 1, which is 0. The cosecant is 1 over sine. Well, that's 1 over 0. Can't do that. That's undefined. The secant is 1 over cosine, which is 1 over 1, which is simply 1. The cotangent would be not y over x, but x over y. That's 1 over 0, and you can see that that is undefined. If we go ahead and fill in 90, that point is 0, 1. So the sine is 1 because it's the y-coordinate. The cosine is 0. The tangent is y over x. That's 1 over 0, which is undefined. Your cosecant is 1 over the sine, which is 1. Secant is 1 over the cosine, which is undefined. And your cotangent would be x over y, which would be 0 over 1, which is 0. All right. Why don't you pause this and fill in the rest? I'm going to quickly also fill in the rest and then come back and check it. Undefined. Cosecant is 1 over the sine, so that's negative 1. Undefined and 0. And we're only filling in the white part. So 360 is going to be exactly the same thing as 0. Okay. I'm going to stop the video and start a second video here.